Hi, am I audible?
Yes, sir.
Okay, so let's wait for 2 3 minutes, then we will start the session.
Okay, sir.
Let's see how many joins, then we will start. Okay, so hello everyone. My
Good
name
evening,
is
sir.
hello everyone. My name is Vijay Mukherjee, and I will be taking this live session for NPTEL course on programming in modern C++. So I'm a PMRF research scholar at the Department of Computer Science and Engineering, IIT Kharagpur. So in this session, we will be solving some problems related to week 7. We'll be having a rough discussion what was covered in that week. Also, this session is being recorded. Feel free to ask any question whenever you have any doubt. So, like anything regarding week 7, you can ask, or anything before that has been taught. So, just let's start then the session for today. So let's do a brief recap of what was taught in week 7. So one of the primary contents that was of week 7 was casting. So previously we have been introduced to like C style casting, uh, C style casting in previous weeks, as well as we are also introduced to the concept of uh, upcasting, downcasting, while we are discussing while we are discussing like class. So during polymorphism, class inheritance. So during polymorphism part, we have gone through these things, terms called upcasting and downcasting. So we had a much like this week covered a much more details how typecasting is done in C++ and what are the types of casting. So like in C style casting, we always had this thing called implicit and explicit casting. So previously we like one of our way to cast was like this int, suppose int I equals to 5. We used to just cast like this. So this was explicit, and for implicit we directly used to do this. So these were some implicit explicit types of casting. So as we know, like implicit casting is not safe. It may lead to data loss. So we have like if you have basic understanding of how C works, so we have seen these kind of things, like suppose double D is equals to 1.47, and suppose I wanted to write int I equals to D. So in that case, i's value will be only 1. So that means this part of the information was getting lost. So this kind of implicit typecasting was leading to data loss. So this is one of the factors. This is not appreciated much. Now coming to what is done in so coming to now what is done in here. 1 minute. Okay, you can access it here. So coming to how we are doing typecasting in C++. So in C++, we have different types of casting. We have const cast, we have static cast, we have inter reinterpreter cast, and we also have another thing called dynamic cast. So one by one we will just briefly understand, like we will go through how each of these casting works. So in constant cast, the main feature of const cast was it, like in simplified term we can say, it breaks the constantness of the data. So suppose I have a string const char star c equals to program. So if I write use const cast here, const cast char star c. So this constantness, like it will not be of type const char star, it will convert to a char star. So this kind of const cast, like this kind of casting doesn't result in no result, no change in data. So whatever was the data stored before, it will still be stored here. So that is the feature of const cast. So a very useful like, so one question may ask, like why we need to do a constant casting sort of thing. So these are different program features or definitions that will you will face while you are doing a system design kind of thing. So in that case, like you need to pass a function. You have a big system, a big C program, and you used to want to use a function call, but that function call only like the function only accepts cat star as a parameter, not a const cat star. So in that case, you may have to just like you don't you can't you face the situation that you can't change the signature of the function because it is a legacy kind of thing. You can't change the code. So one simple solution is that you just break the constantness of your of the variable you want to use and just pass it there, and whenever the result comes you again make it a constant variable. So that is one way you can do it. So that is one reason that this kind of casting is allowed. So next, the other kind of casting are quite different from this one. So next we are introduced to static casting. So in static cast, so a simple way of remembering this, static cast are generally in static cast is quite like the explicit way of doing the like explicit C style casting. So like what you used to do, like I is equals to double d is equals to int I, this kind of. So its equivalent will be d is equal to static cast int I. So these statements are equivalent. So how you used to do explicit casting in kind of C++C, so static cast kind of does the same. So don't like some might just like get confused with the static term because we have used the static term previously in some other place, like when we are defining class, so we have used the thing static. So this is different static. So in static cast, what we have seen is so these kind of normal conversions can happen, int to char, float to int. So these kind of things can be used done using static cast, as well as int star to cat star. These kind of things all can be done. But by definition, C++ allows out another kind of casting function, that is reinterpreter cast. So in reinterpreter cast, it is generally available to only pointers. So using reinterpreter cast, you only be able to be able to use for casting pointers. So from you want to convert a int star type pointer to a double star pointer. So those kind of thing for exclusively we use reinterpreter cast. So in static cast can do all of that, but it is always safe to use a particularly reinterpreter cast for in case of pointers. Right. Another type of casting C++ allows, that is dynamic cast. So this is a little bit different. So up to, until now, whatever casting we have seen, all used to be done at compile time. All this casting thing used to be done at compile time. Now, dynamic casting happens on runtime, and one of the major thing that typecast allows, static cast allows, was upcasting and downcasting. So, and using upcasting and downcasting using static cast is very unsafe. Reason, it does no sanity checking. So it converts one data type to like class to another class, base class to derived class and derived class to base class, respectively, without checking that object of that base class is available or not. Right. So that is a big problem, that static class, that this upcasting and downcasting have in case of static casting. But in dynamic casting, this sanity checking is done. So whenever we are trying to upcast, we are trying to downcast in dynamic casting, it returns a null if no object of derived if no object of base class is present. So that sends a null. If it is if a object of base class is present, then it doesn't throw those kind of null, those kind of exception or null in the output. So anyway, so we will like for thumb rule, you can say always use static cast for normal variables like int, double, etc. predefined. Always use dynamic cast if you are using, if you have a virtual functions kind of thing or you are using classes. So always try to use dynamic, and use reinterpreted cast in case of when you are dealing with pointers. So this can be just used as a thumb rule. Other than that, we also had a brief overview in this like in this week about two more things, uh, that is virtual table. Now, regardless of what your understanding of virtual table, the main crux of what virtual table is used for is to just to so that the class, whether it is base class or derived class, have an idea of which function to call. Like you have seen that when you are using a keyword like virtual, you are if the base class is also able to like the base class pointer is also able to call the derived class pointer. So how it is able to know like which class, which object, which function to call, derived class object or derived class function or base class function. So this virtual table helps them to understand. So like every object has a virtual table, and the virtual table will be able to tell it the pointer that okay, this object can call only these sets of functions. So that's the reason virtual table is very important. The other thing we were introduced to was multiple inheritance. So previously whatever inheritance you have seen were of the type this. Now in multiple inheritance, what happens? You can have more than one base class, right? This we have seen like what happens in case of multiple inheritance. Like you need, so this and this can have functions of same signature. So these are the, or even variables of same name. So in that case you need to use that using scope resolution operator to identify these D will use which of the functions, and even which like if they have I and I, So you need to then say using v1I. So this kind of way you need to remove the ambiguity we have seen. Other than that, we have also come across that diamond problem where this inherits this, B and C inherits A, and D in turn inherits BC. So we have seen that we need to define, use virtual in case of this kind of inheritance, so that only one copy of or like members of A gets ultimately in D. No two copies are maintained. For two copies are maintained if we are using no this virtual inheritance thing. So these kind of problems was discussed. So let's now look at uh, the exercises, and we will try to solve them. So any doubts regarding like whatever I discussed now, like what is virtual table, multiple inheritance, and the castings?
Sir, can you explain the dynamic cast once again?
Yeah. So yeah. So dynamic cast is kind of a runtime cast, right? Okay. So let me erase a little bit. So one thing I will say that whatever thing static class can do, dynamic dynamic cast can also do. Okay, that is one thing. Let's clear it out. Whatever static class can do, cast do, dynamic cast can also do. But there is a major difference. So by default, you have seen upcasting is allowed in C++. But using static cast, you can forcibly do downcasting as well. So like you have a class A and something like class B, public A. Okay, so now uh, B's pointer generally cannot hold a, suppose we have a, so like this is generally not allowed. So this is not allowed, like simply not allowed in C++. But using static casting, like you can allow this. So b asterisk p is equals to uh, static cast, let's say let's say a star percent a. So like b star ampersand a. So like here, like using static cast, this is allowed, but as you know, see, this is very unsafe way of doing it. So this is not safe. And so suppose if you want to call any function using p, so this may lead to some kind of crash in runtime. So this is not a very safe way of doing this. So now if you used, instead of static cast, let's say you have used a dynamic cast. So let's say you have used something called like dynamic cast. So this will return a null pointer to p. P's value will be null. So why? So it is telling that, look, this is not a is not a object of, a does not contain a object of object of type B, so I cannot do it. So in that sense, this kind of downcasting is not allowed. So it will, that sense, it is a very safe way of doing this. So when you are using typecasting, so you are writing the code and you are trying to run it, the programs gives a segmentation fault kind of thing, so you are not able to understand why it is happening. But when you use a dynamic cast, so at runtime it is deciding that, look, a is not a valid object of B. So this is not correct, so it will just give a null. So this kind of sanity checking dynamic casting occurs. So the reason it is able to do it, because it resolves these things at runtime instead of constant time, compiler time that static casting does. Does this at dynamic at runtime. So as a result, this is a very safe way of doing it. So there will be no seg fault. It will just return a null value, and using a null check, you can say that, okay, this is a wrong code. So that is the main difference between static cast and dynamic cast. Other than that, both uses are same. Okay, now clear.
Okay, sir. Thank you, sir.
Okay, so like if you have any more doubt, we will be solving exercises regarding this, so you will be more like easy to understand for you then. Okay, so let's jump into the exercises. So this is first question. So you have been given a class and you have to fill out what happens. What we'll fill at line number 1. So let's like go through the code once. So you have a class of type like employee. It has a private data member name. It has this constructor. It has an update function. It has a show info function. Now it is declaring a constant employee, constant data type employee E. That means this E is of type const. E is a constant. Now we are telling it will show info. So we have to place something in line 1 such that it can print Samir, that has been used here. So now what will be placed here? So now you have been given this option, so we'll go through one by one. So now what is happening? So we have a constant or object E of employee class, and it is trying to update it. So now if we use just this here, what will happen? If we use just this here, then it will throw a error. Why? Because E is a constant and you are trying to update a constant. So we know once constant value has been declared, you cannot change it. So this is not allowed. So this will just throw an error. So as discussed, this is the reason where we will use const point like const cast, constant type casting, because to break the like constantness of the object, you can say. So we will write here const cast. What is will be this? What is this? This is an employees type pointer. So this will just break the constantness of this. So this was previously this was constant. Now no more. So this will just break the constantness of this. So it will update the value of name to Samir using this, and that will print the correct answer. Now static cast won't do this because it will, if you try to do this, it will throw an error. We are trying to convert const type to non-const, so this will throw an error. Similarly, dynamic cast will also throw an error, const to non-const conversion. Now this will not throw an error. This is a C type conversion, and here you see we are trying to convert this to a const type, non-const type. So this will not throw an error. So both A and D are correct in this case. But let me be clear. When you are writing a C code, don't C++ code, don't use this kind of format. This will just like writing a bad C++ code. Always use this kind of casting operators, const cast. So this will already give a correct answer, but like this will slow down the process. You are writing a C++ code, so always write cast when you are trying to cast using this kind of codes. So A will be the correct answer. Any doubt regarding this?
No, sir.
Okay. Okay, so let's go to the next one. So you have another code, and you have to specify which cast operator we will use here. So you see you have here a increment function incr. It takes like pass by pointer, and it updates the value by 1. Right, so now the main function, we have x whose value is 5. Now we are storing the address of x into a constant integer pointer. So the value that is stored in this like ptr, that is pointing to x, so this is now becomes a constant. So now like we are passing, we have to pass something there such that a value of x becomes 6. So basically 5 becomes 6, something we need to pass here. So again what we need to do, so ptr is uc of type incr, of type const int, and it accepts only int type. So again you will use that const feature. So you will use const cast int star ptr to break the constantness of PTR. So once it goes here, it is able to do it. So it will print 6. 5 will be passed it here and it will print 6. So correct answer will be 2A, cast. Okay, so let's go to the next one. So this one was similar to previous one. Okay, so now we will have a problem regarding the virtual function table. So you have been given a class A1 has a virtual function f and a normal function g. Now A2 has a virtual function g. It has h and it has I, virtual function I. Now A2 inherits A1, A3 inherits A2 inherits A1, A3 inherits A2. Now it has its own G and it is a virtual void H, a virtual function H. So you need to write what will be the virtual function table of A3. Virtual function table of A3. Right, so what will be the functions that are available to A3? The functions that will be available to A3, if we go through it, A3 will have G and H that are given here, as well as since it is like inheriting I, it will inheriting A2, it will have I, and since A2 is inheriting A1, it will have F. Right. So let's check whose functions it will use. So for G, it has its own G, and it will not be using this G. So it will have A3's G. Now for H, it has its own H. So it will be using A3's H. Now I, it has no I of its own, so it will be using A2's I. Now let's come to F. It has no F, no, so it just does A2 have F? No. So only A1 has F. So it will be using A1's F. So that is the basically the BFT of A3. So which of these options? A1 F, A3, GA3, HA3, so this will be the correct option. So this is the virtual function table of A3. Right. So like if anyone asks you what is the virtual function table of A2, what it will be? So first you need to check what are the functions it will have. So it will have a G, it will have a H, it will have a I, and it will have a F. So it has its own G, so it will have A2G, H, it has its own H, so it will be A2H, it has its own I, so A2I, and F will be of A1. So this will be the virtual function table of A2. For A1, it has only F and G. So F will be of A1 and G will be of A1. Any doubt regarding this? Void age is in A2. Yes, is not virtual, so it will not get added to. Oh, okay. So I just mentioned it as like what are the functions available to him. So it will not get added to uh, just just a way of saying that what are the functions available to him. It is a nice way of understanding, easier way of understanding that. Okay, so let's. If I have any doubt regarding this, you can ask, or I will go to the next one. Okay, so let's go to the next one. So you have this. So you have this like four classes. So you have class A, class B, class C, and class D. So you have a diamond structure like this: A, B, C, and D. So we have declared, yeah. So this has a. So the question is how many virtual tables will be created for the following class for the following classes. So you see B has a virtual function if C doesn't have any, A doesn't have any. So B will have a virtual function table, and since B is being inherited by D, so D will also have a BFT. So only two classes B and D will have a virtual function table. So 2 is the correct answer. Any doubt regarding this?
No, sir.
Sir, please repeat it again.
Yeah, coming. Okay. So let's. So you have like if you check the structure, you have a class A, a class B, which is inheriting a class C, which is inheriting A, and a class D, which is inheriting both B and C. Now you see F has B has a virtual function, B has a virtual function F, right? So it will have a virtual function table. So that will have a virtual function table, and now D is inheriting both B and C. So since D is inheriting B, it will have this virtual function with it, virtual void f. So D will also have a virtual function table. So whenever a class has a virtual function, or if any child, and so that will create a function table, a virtual function table, and any child of it will also have a virtual function table simultaneously. So in this case it will be 2, B and D. Clear now?
Yes, sir.
Okay. Okay, so let's come to this one. So you have given two class, st1 and st2, and we are creating uh, two objects like pointers, uh, st1 star and s1 and s2. So question is, which of the following typecasting is permissible? So let's look at them one by one. So first one is s2, and what we are doing, we are taking s1 and we are static casting it to s2. So is this allowed?
No, sir.
So that is the problem. Okay. So it is allowed. Thing is, it is allowed. It is not allowed. Sorry. So it is not allowed. The reason is, these are two different classes, st1 and st2. So these will throw an error. Cannot convert uh, this kind of two different elements. So if you have seen the lectures, this can be done using that thing called copy constructor. So if you have a copy constructor here, st1, st2, a, so that would have allowed you to do this thing, but this will not be allowed in this case. So the next is, we are trying to do the same using dynamic cast. So whatever static cast is not allowing, same dynamic cast will not allow. So it will also throw the same error. Both are of different types.
One is correct.
So this one is wrong. So let's come to number C, reinterpret cast. Uh, so will this be allowed?
Yes, sir.
So one of the reason this will be allowed is because we are here dealing with pointers.
Pointer.
So what happens in case of pointers? So it doesn't check this kind of types and all. So it basically checks, yes, you are pointing to a chunk of memory and I am pointing to a chunk of memory. So just do a mem copy here. So as a result, this will be allowed to do. So that is one of the main reason why, what is the difference between a static cast and a reinterpret cast kind of thing, because one deals with objects, or you can say just data members. But in interpret cast we are dealing things in pointers, so it allows this kind of things. And const cast is not, because obviously this is not a constant type thing, so constant will is not permissible. So only option C is allowed. So correct option is C. If you have any doubt, you can ask regarding this.
No, sir.
Okay, so let's go to the next one. So let's come to this problem. So it deals with this thing called type ID. So type ID basically prints, like it returns type ID dot name. So it returns the type of the object, or let's say content. So if I write int I and I try to print type ID I dot name, it will print int. So it tries to print the name of the object or the content, whatever it is that. So here we have a base class, and here you have a base class has a virtual destructor, and you have a derived class. And so we derive and we create an object of class base and class derived. Then we uh, create a pointer dp which points to derived class object. We create a pointer bp which stores this derived class object. dp is a pointer to, so this is d, our derived class object. dp points to it, bp also points to it, and dpp we are saying we are converting, we are casting dp to derived type. dp is already derived type, we are again casting it. So this is also holding same thing. Now we need to check, we are doing some kind of comparisons here, so we will go over one by one. So what is the first one comparing? So we are comparing type id dp dot name is equals to type id bp dot name. So what is type id dp dot name? dp is basically derived star, is comparing to bp dot name. bp is base star. So is this comparison valid? No. So this will return a 0. So the first one will be 0. Next is this one. So we are saying type id value at dp. What is value at dp? Value at dp is d. So that is basically derived. So value at dp, type id value at dp dot name, that is of type derived, is equals to value at bp. What is value at bp? d, which is of type derived. So both are same, so it will return 1. Next, let's come to this one. So you have type id bp.name. Type id of bp is base star, and type id of dpp is derived star. So these are not equal, so it will be 0. And last is type id of bp value at bp. Value at bp is d. What is d? Derived. And value at dpp. Value at dpp is d, so that is also derived. So these are derived, so it is equal. So the correct answer is 0 1 0 1. So this will be the output. So any doubt regarding what type ID is? Please, does type ID contain static or dynamic type information of an object? Very good question. Does type ID contain static or dynamic type information of an object? Static or dynamic type is basically maintained using yes, it can maintain. Yes, sorry, it can maintain. So if you have seen the example in the class, let me open the slide once. So I guess it was there once, or let me explain it here only. So if we are having a polymorphism kind of setup, class A, virtual something, virtual, suppose void update class B void update. Now we declare a star A is equals to new B, right? So if you give type id of A, it will give you suppose you don't have this thing virtual, so it will give you value at A is A star, and type id asterisk A will become, in that case, it will say it has a type of A. Now you have, if you have this virtual thing, it makes the thing different. So type id of A will remain A star, but type id of asterisk A in that case will become A. Sorry, B. Right. This is what happening here also, right? So you see, base is able to say it is a D's pointer. That is only reason, because we have defined it as virtual here. this base pointer. So that indicates we are having a virtual sort of polymorphic class here. Yes, it is a dynamic information type information. Yeah, it was a like a good question. So like how does type ID maintains the thing? It is dynamic or runtime static? Okay, so let's come to this one. So you have a so it has three parts basically. Uh, so you have a class, base class, and a base class, and you have a derived class, and we are we have a like main function here. We are trying to do some kind of casting using a try and catch block. So this try and catch block you will come to later part of this course, maybe in week 9 or 10 maybe. So just let me just give you an what happens in a try and catch block. So so if you write anything in try and catch block, so whatever you write here, so if it generates an error, like error in the sense uh, like a warning, so this kind of thing generated will be caught. So let me give you a simple example, much simpler example that will help you. uh, so a try catch block, suppose you are trying to do a division by 0, so that is not legal, right? That is illegal, that will throw a error. So what happens in this catch block, this exception, this this will be filled with some value. So this will contain some string element. So it may be division by 0 not allowed. So this kind of thing allows you to do sanity checking of your code. So whatever wrong is happening here, it doesn't break the code, right? It does a sanity check and it comes here. So if this fails, you can write simple some code here that will be executed when this try block fails. So that is how try and catch block works. So this is a concept which is like very common in when you are doing this thing called Java programming. So Java has this very good try and catch block thing. So C++ also introduces part of it here. So let's not focus much on the try and catch block and more focus on what is the wrong it is happening here. So which of them will throw a error kind of thing? So let's look at them one by one. So you have line 1, we are trying to doing a static class. So you have a base class object OBB and you have a derived class object ODD. So you are trying first to do a static cast. Static cast of OBD to RA1. So OBD is derived class and we are trying him to store in RA1 which is a base class. So this is basically upcasting. So you know upcasting is allowed, so this line will work fine and this will print uh, uh, very so r1.f will, since it is a virtual function, it will print derived, right. Next line we do base array2, and we try to give uh, a dynamic cast, and we try to give OBD here. So again, uh, this is correct, this is doing an upcasting, so this will not throw any error, so this will be also correct, and array2 will get executed, and array2f will basically, since it is a virtual, it will print the correct one, derived. Next we are doing a sort of downcasting. We are basically giving a derived class object rb1 the base class pointer, and we are doing it in static class. So it is downcasting, but static cast allows this, so it will not throw any error, so it will simply cast it to them that, and it will print rb1 f, so it will print this one, so this is the f. So even though it is like a bad way of doing it, but since the object is of type b, so it will do it, so it will print base. Now next is this one, so you see it is again trying to do the same using using dynamic cast, and as I said, dynamic cast doesn't allow this kind of things. It will do a sanity checking, so it will throw a bad cast. Since it is like not allowed, upcasting is not allowed, but and upcasting is allowed, but this is not a safe type of upcasting. It allows upcasting if let's say uh, this upcasting, let me write the statement, this would have been allowed. rb2 is equals to dynamic cast derived ampersand derived ampersand, which one is RA2. So if you are doing this, see, this is a base class which is holding derived class. So when we pass it here, so this is a base class holding derived class, so like that would have been given as that will not have thrown a base bad cast. So it allows that, it does not allow this one. So also, though it is printing a base here, so suppose it doesn't have an if it didn't have an if, what would have happened? It will just basically being a segmentation fault kind of thing. Even though the casting is allowed, it is not safe to do. So that's all about like how like why dynamic cast is better to use instead of a like static cast. So any doubt regarding this? Like this is very important, like why to use why it is better to use a thing called like dynamic cast, because it is safe way of doing it, and whereas static cast, it does all this sort of nonsense of like casting anything to anything, and that will be just, while it will not throw, it will get compiled correctly, it will basically throw an error like it will basically give a seg fault, like when you have like it is trying to illegally use some kind of a memory. So it is not better to use dynamic cast in those sort of sense. So is this clear? Okay, so let's go to the next one. So here you have like uh, a class. So you have a class A and two classes B and C, right? And you are doing some kind of casting operations here. Four kind of casting operations here. And if you have a overview of the code, you will see both are basically checking whether the cast is valid or not, sort of thing. So you have a class A and B is inheriting A and C is inheriting A. And so let's we are creating an object A, obj of A, and we are creating an obj of B. So now first one is we are doing a casting of object of B to A. That is basically an upcasting. So PA will definitely get a value because it is a static cast. So the output in this case will be cast 1 valid. Now we are doing is PB we are doing a static cast using PA. So that is basically, you can say it is basically PA to PB. So basically we are downcasting. Again, that is also like since it is static cast, it will always return a correct. It will not return a null. It will return a correct value. So it will, irrespective whether it is permitted or not, safe or not. So it will give cast to valid. Next, let's come to this one. So this is saying C is equal to C star equals to PC dynamic cast a new A to C. So so it is doing a basically downcasting. So as you know, as you see, here is a fallacy again, the fallacy which we have discussed before. So downcasting is allowed as long as it has a valid object. Now new A is not a valid object for C, so it is an object of A type. So this casting is not allowed. So this PC value will come null. So because in dynamic cast, if it is not valid, so it will give a null output. So PC value will be null. So in that case, it will print cast 3 invalid. Now cast 4, what we are doing, we are trying to uh, obj 5, we are trying to cast B to C. Again, this is not valid, right? Because this is a uh, runtime casting, and it says checks that B is not a valid object of C. Since B is not a valid object of C, so this will also return a B is not a valid object of C. So this will also return a null. So this will also print cast 4 invalid. So the correct option is cast 1 valid, cast 2 valid, cast 3 invalid, cast 4 invalid. So correct option is option A. Clear this one? So this one again also deals with the same kind of thing, that whether the casting is valid or not, and it also checks that simple nuances, that what is a dynamic cast, because it checks it dynamically at runtime, and the static cast is a compile time casting. So that's a main difference of uh, how this kind of casting works. So always dynamic cast is the best way to do it. But if you want to force it, like you want to forcefully allow B to C those kind of casting, then static cast can use. Even static cast does not allow a B to C, because those are different kind of objects. uh, Static cast allowed A to B kind of conversion, right? B2C, if you have to do B2C, you have to use that like reinterpreter cast, because those are of different type, only pointer type variables they will allow. Clear this one? Okay, so let's go to the next question. So here you have, this is a very fun uh, problem, and it is quite tests to the fundamentals of casting. So you have you have a class A, int A, and you have uh, like it has a data member A, it has uh, like a constructor B, it has a get function and a set function. Next you have uh, class D, which inherits B. So D is inheriting B, and you have a constructor uh, int x y, it takes 2, so is initializes its own data member, and then also calls the constructor of B. It has a change function which changes the value of a and b, so it calls the set function to change that, and c, and it has a print function to print the value of a and b. So we declare an object of d, and we call change, and we print it. So what will be the output of this? What will be the output of this? Anyone? So please try to do. I will solve it later. It will be very fun to see how many can get it. So you have some time. Try to do it. Please, it will be like any any answer will be good if you can give. So forget that this. Let me say that all the answers are wrong here. So all the options given here are wrong. So what will be our natural instinct? Say that what will be the output of this? Let's say you have not been given these options. Like what you will think. So let me say that all of them are wrong. So what will be the thought process, that what will be the output? Anyone? So I have we covered so many problems in casting. So this should be just cakewalk for you. Okay, so so let me give you a option. So D we are passing 10 comma 20. It comes here. It is a static cast of this to B type. So basically this here becomes a B type object, B type for variable, and it calls its value, its member function C. So that means with C. So basically it is saying that we are passing 7 to this, and then it becomes value of A becomes 7 plus 1 is equals to 8. Similarly, B's value become C plus 1. Sorry, it was previously 10. Sorry. A's value was 10. 10 plus 1, it becomes 11. And this one becomes, what am I doing? sorry, a's value become, since 7 is present here, 7 plus 1 is equals to 8, and b's value become, sorry, 7 plus 1 equals to 8. So on a naive solution, you can say that the output will be 8 comma 8, right? This is a very naive solution, and you can say that, yeah, this will be the output. But what's the issue? This doesn't match with any of the output, like given output value. The reason is a very minute thing you need to observe here. So notice this statement: static cast B star this dot set C. So when you are static casting like this, okay, so this is basically creating a object of B, creating a object of B, and the new B, that object, so let's say it is a temp obj, and that is setting the value of 7. There the value gets updated as 8, whereas the a here remains as 10. And you can ask the question why this is happening. The thing is very simple. As we have discussed in previously, static cast is quite equivalent to the explicit cast what we have seen in C. So if you write double D is equals to int of, say let's say I, where int I is equals to 5, since this D and this I are different thing. This D in a different memory space and this I is in a different memory space. So this is basically D and this is basically I. I is 5 and now 5 is being stored in D. And exactly that is happening here. When you are static casting as B, this is basically creating a copy of B. Right, so this is basically creating a copy of B, but not that B, that this is not being, so it is creating a copy of this, not the actual this. So as a result, it can set the set function is called, it's local to that temporary object. Now if I want that value of 8 comma 8, I want to change that that one only, that B only. What I need to do is I need to write it as ampersand. So when I write it as ampersand, I am basically casting it as a reference of this object. So when that happens, so what happens there, that both are sharing the same memory space, just a rename. So this temporary object will basically this only, just using a same different name. So that will sort it to 8 comma 8. So all the things we discussed previously you need to go back and check which of them we have used an ampersand, which we have used a star, and which of them we have not used anything. So whenever we have not just written B or A or something like that, that we are basically creating a copy of that. When we are creating when we are casting it, we are casting it into a copy. But when we are using an ampersand, we are basically using the same one. We are basically creating a reference. So this is very important and it is very minute. This saves you a lot of space whenever you are doing a programming. So whenever so if you are writing a long program and you are always using static cast B, static cast B, static cast B, in that case you are creating a copy and copy and copy and copy. But you don't need a copy. You just put a reference and do it. So this very minute thing will save you a lot of time and space. Okay, so the correct answer in this case will be 10,8. So if you have any doubt regarding this, you can ask. Okay, so we will go to the next one. So if you have any doubt up till now, you can ask. So like so like here, see, here is a way you are basically doing a reference thing that we are discussed now. Uh, so let's see some more. So these are all pointed types. Uh, these was const, so we don't have to think about it much. Const also same thing. If you have an asterisk, it is basically a reference copy, or if you don't have an ampersand, then it is basically just normal copy. So okay, so let's come to this. This was part of your assignment this week 7. So let's like try to solve it. So you have been given. So this is a sort of fill in the blanks. So you have like a class here, test1. It has a private member A. You have a class B here. It has a private member B. Now you are this is the main function and this is some function fun that have been written. It takes in uh, two parameters, const test1 ampersand t and an intx. And then it does some sort of like test1 something u dot show and test2 v equals to x some v dot show. So the thing is, it creates an object of class t1 and it takes a int x. It takes an input of x and then calls t1x and it will print something like Okay, so if 4 as taking as an input, so it returns 10 and 14. So u dot show is basically a object of t1. So it basically shows 10 and v shows uh, so 10 is its natural. So that is, it will always, the first output will always be 10. That is not a issue. So basically line 2 will be, since this is a const type, uh, so line 2 will be basically, you have to break the constantness. Const, otherwise we will not be able to use this. Const const cast of type test ampersand. So this will be here, because we are creating a reference. So it will be of type test 1 ampersand. I'm writing it so bad. Const cast test 1 ampersand. So that will be good enough, so that we can use this show operation. Now test 2, the x is 4. So basically we are printing 10 plus 4 equals to 14, right? So we need to pass something here, so that v dot show gives us the output of 14. So what to do? So here you see, uh, we need to we need to cast, since u is of type test 1, we need to cast into test 2. So we will be using static cast, or will static cast we do it? Will static cast be able to do it? What is the problem with static cast in this case? Static cast will not allow the stupidity of casting one class to another. So we have to use re-enter cast test 2 ampersand. So that will be able to cast u to v, right? So interpreter cast is the correct answer. Now v equals to x, so we will write operator equals to int x. So this will print b is equals to b plus x, right? So in this case, since when we are casting this, so in this case this int, here it was storing 10, so this 10 gets superimposed here. So earlier if it has to use 20, so this gets superimposed here, so it becomes 10. So this 10 plus 4 equals to 14. So that is how 14 will come here. So the correct answer is this. So you understand what is happening here. So we are using a const cast to break the constantness of this. So this is basically what? Pass by reference. Now we need to break the constantness of t. So what we do is test1 ampersand u. So that's how it is now. Now we need to convert between two different class, test1 and test2. Static, so that static and dynamic cast don't allow that. So we need to use reinterpreted cast for this. So reinterpreted cast converts it, and now you see why reinterpreted class allow this, because uh, also one of the thing, so okay, it is allowing it. So one of the reason it is being allowed because both have the size of same. So basically this size of this will be 4 and this will be 4. That is basically the size of the INT. So the value of this b will become 10. So because it was storing 10 in t1, so that 10, now we are doing an equivalent. B equals to x. X is basically int type. So to do that, we need to do an operator overloading. So we write operator equals to int x, and there it does b equals to b plus x. So 10 plus 4 equals to 14. So that is the three statements we need to use to overcome this. Any doubt regarding this, you can ask. Okay, so let's go to the next one. So here you have a class int string, and it has a few integers. So it has an integer type, integer pointer. It has an integer n, and we need to fill some things here and something here. So let's see what it wants. So basically it takes in a few integers and it does some kind of rearrangement. So so we need to check what we need to put here. So first we are creating, we are taking in the number of inputs, that is 3. So intk, so input is 3, so that will create an object here, so with the value k. So that will define the value of n k 1, another will be we will create this array, so that will be new arr arr new int n. See, because they are using that value to traverse it. Yeah, so after that after that so that clears this out. So now we do a static cast. We now do a is equals to k. Now when I do a is equals to k, that means a is equals to k, that means we need to have something called uh, for this equal to operator, so that it will be operator equal to, so that this value of k comes here. So it takes the value of k, that is 3, and then takes the input, and then it gets stored in this array. So that will be 1 2 3, right? Now it prints that in reverse order, so that is that happening here. So we are doing a static cast of int type here. Now we are saying we are doing a static cast of int type here. So that for that doing that, we need to put something like this: operator int type this. So that will basically allow this kind of casting. So basically this kind of casting is not allowed. So we are trying to do, what we are trying to do is, we are trying to cast int string to integer. So that equivalent we can say is writing int of a int string type. So that is not allowed. So for that we need to allow this operator int type to do it. So that will solve this issue. New int or that, I the second one, because you need to allow you need to say that number of elements you need to create. That is the issue. So any doubt regarding this? Okay, so let's go to the next one. So you have a class char, and you have a main type object. So you need to define what will be the different like what is that happening here. So we are doing basically three things. We are doing a cat type casting, we are doing an int type casting, and we are doing an equal to, right? So basically uh, char cb, so that we will return the character char cb. So basically int a, so this one, so this one is basically the class car. So this one is basically your uh, class char suppose underscore ch. So this is basically your uh, constructor, so it does that. Now you have a character type, so that will return the character. So this will be your operator char, and this will return the position, so that will be basically int type. So that is basically this conversion, operator int. Okay, so that is how you do it. So one of the lessons we learned from this is operator char operator int basically refers to the explicit C-style conversions that happen always. So that is also kind of operator. So this is also kind of operator, and we can overload them also. By overloading them, we can allow this kind of casting to take shape, where we are basically uh, like yes, we are they are doing casting, but they are also turning different type of objects or values. So that is one thing this operator overloading of casting operators does, right? So that is the question. So this is the last one. So this is the sorry, I forgot to draw it. So this is basically the diamond problem of sorry. So this is the diamond problem that happens in case of uh, diamond problem of inheritance. So like whenever you go for a like an interview of like uh, tech company, so so if you like mention C++ in your resume, so this is a very important question that they ask. So what is the define the diamond problem uh, C++ in C++. So then you have to say that what happens in so you need to learn this very interesting part. And also they ask how do you solve the diamond problem, so then you need to show them the thing called virtual inheritance and how it happens. So basically what is the diamond problem? So basically when you have this name and code, so one copy of this part comes from here and one copy comes from here. So when you are initializing a master object of master, so you when a constructor of master is called, so it basically calls constructor of this and this. So this will also call this and this will also call this. So these are basically, you see, two copies of these are being created. So if you mention this virtual keyword while doing an inheritance, so virtual person, virtual public person, at that point and you do virtual public person in this case. So whenever you do this, so only one copy of person in master is present. So that is your like diamond problem, and how do you solve it? Meaning, if you have a complex design structure where one inherits multiple and multiple inherits multiple, that in that case this comes handy, this virtual function thing, and helps in your like modular design kind of approach. Okay, so with that we come to an end of today's discussion. So if you have any doubt, you can ask regarding any of the questions. So mainly we discussed today was different kinds of castings: static cast, constant cast, static cast, return beta cast, dynamic cast. Also we discussed what we call as virtual table and virtual function table. Also we discussed multiple inheritance and the diamond problem. So if you have any doubt, you can ask, or it is done for today. We'll meet in the next class on next week. Thank you everyone for joining. Yeah, thank you everyone.